Good morning, students. Today we will solve some numerical problems of the first chapter, electricity. You will see the question over here. First question is given: when a 4-volt battery is connected across an unknown resistance, there is a current of 100 milliampere. You have to find out the resistance of the circuit. Say, what is the information given over here? Potential difference V, that is equal to 4 volt, and a current of 100 milliampere. You have to convert it into ampere first. That means 100 into 10 to the power minus 3 ampere. So its result is 10 to the power minus 1 ampere. This is current. So you have to find out the resistance. So V is equal to IR. This is from the Ohm's law. We have to find out resistance. So resistance R equal to V by I. So V is 4 into I is 10 to the power minus 1. 10 to the power minus 1 comes up. It is 40 ohm. Okay. So resistance of the conductor is 40 ohm. This is our first question. So correct answer is 40 ohm. Now the next question given. Question is, calculate the energy transferred when 2 ampere current flows through a 10 ohm resistor for 30 minutes. Energy transferred when 2 ampere current. So here the question is, current is 2 ampere. Information we have to write down the information first. So current is 2 ampere. It is passed through a resistor whose resistance is 10 ohm, and current is passed for 30 minutes. So time is equal to 30 minutes. So firstly, we have to convert the time into second. So 30 into 60, that is 1800 second. That is the time. You have to find out the energy transferred, and here energy is nothing but the heat energy, and its formula is H is equal to I square RT. I is given, that is 2 whole square. R is also given, that is 10 ohm, and time is 1800 second. So by calculating, we get the energy transferred in the resistor. I repeat the solution once again. In this question, current is given, that is 2 ampere. Resistance is given 10 ohm, and time is 30 minutes. Firstly, we have to convert the time into second. So that is 1800 second. Now we have to find out the energy transferred. Here energy transferred H equal to I square RT. We have to put the values of I, R and T, and finally we get the energy transferred in the form of heat. This is the first question of question number 2. Now we deal with the second question of question number 2, that is, calculate the amount of charge. You have to find out Q that would flow in 1 hour. Time is given, that is 1 hour, through the element of an electric iron, drawing a current of 0.4 ampere. So you see what informations are given over here. So I is given, that is 0.4 ampere. Time is given 1 hour. You have to convert it into second. 1 hour means 3600 second. You have to find out the amount of charge. We know the formula of current. I is equal to Q by T. From here you get Q. Q is equal to IT. We know the value of I. It is 0.4, and time is 3600 second. So by calculating, we get the total charge transferred, and that should become in coulomb. I repeat, a current of 0.4 ampere is passed, so I is equal to 0.4 ampere for 1 hour. So time is 1 hour, that is 3600 second. You have to find the charge transferred. For this, we are using the formula I equal to Q by T. So Q equal to IT. We know the values of I and T. Putting the value in this equation Q equal to IT, we get the result. This is all about the question number 2. Now, question number 3. A 4 ohm and 8 ohm resistor are connected in parallel. What would be the combined resistance of the system? See, when the resistors are connected in parallel, then the equivalent resistance is 1 by Rp equal to 1 by R1 plus 1 by R2. And that is a formula for finding the equivalent resistance in parallel. And here the two resistances are given, 4 ohm and 8 ohm. So 1 by 4 plus 1 by 8. Taking LCM, it is 8. 4, 2, 1, 3 by 8. So equivalent resistance Rp would be equal to 8 by 3 ohm. So two resistances are given, 4 ohm and 8 ohm. They are connected in parallel. So in parallel, the expression of the equivalent resistance is 1 by Rp is equal to 1 by R1 plus 1 by R2. In the place of R1 and R2, you have to put the values, and finally we get the equivalent resistance in parallel, that is Rp equal to 8 by 3 ohm. This is question number 3. Now, question number 4. Here it is given two identical resistors, each of resistance 2 ohm, are connected in turn in series and in parallel to a battery of 12 volts. Ratio of power consumed in the two cases. Okay. So in the first case, we have to find out the equivalent resistance in series, that is Rs is equal to R1 plus R2, both are equal to 2, so that is 2 plus 2, 4 ohm. Okay, and potential difference is given, that is 12 volt. Power consumed in the first case, let us consider it as P1. P is equal to V square by R. Here R is Rs. That is in the first case. Now the same resistors are connected in series, parallel. In that case, 1 by Rp is equal to 1 by 2 plus 1 by 2, that is 1. So Rp is equal to 1 ohm. In that case, power consumed P2 is equal to V square by Rp. We have to find out the ratio of power consumed, that is P1 by P2, that should be equal to P1 is equal to V square by Rs into here the Rp by V square. V square cancelled out. Rp is 1 and Rs is 4. So ratio of power consumed, that is P1 is to P2, that is equal to 1 is to 4. So this is the ratio of power consumed when two resistors firstly connected in series and then in parallel. I repeat the question once again. Two resistors, 2 ohm each, are connected in series first. So we get the equivalent resistance in series Rs, that is 2 plus 2, 4 ohm. Potential difference is given, that is 12 volt. So power consumed in this case, P1 is equal to V square by Rs. In the second case, resistors are connected in parallel. So 1 by Rp equal to 1 by 2 plus 1 by 2, that is 1. So Rp equal to 1 ohm. We again calculate the power consumed in second case, that is P2 equal to V square by Rp. Now we find the ratio of power consumed, P1 by P2, that is V square by Rs into Rp by V square. V square cancelled out. Rp is 1 and RS is 4, so that is 1 by 4. So P1 ratio P2 equal to 1 ratio 4, and that would be the desired answer. This is all about the question number 4. Now we'll deal with the question number 5. Say, a 100-watt electric bulb is connected to 220-volt mains power supply. Calculate the strength of electric current passing through the bulb. See the information is given over here. Power is given, that is 100 watt. It is connected to 220-volt mains, 220 volt. You have to calculate the strength of electric current, that is I. We all know the formula, that is P is equal to V into I. Power equal to potential into current. Power is given 100 watt, that is equal to volt, 220 into I. So current is equal to 100 by 220, 0 cancel out, 2 5, 11, that is current is 5 by 11 ampere. Again I repeat the solution. Power is given 100 watt. Potential difference is given 220 volt. You have to find out the current. We all know the formula power, that is V into I. So in the place of P and V, we put 100 and 220, and by calculating, we are getting I equal to 5 by 11 ampere. This is about the question number, first question of 5. Now the second one. If the same bulb is taken to USA, where the main power supply is 110 volt, how much electric current will pass through the bulb when connected to the mains? Now it is same bulb, that is 100 watt bulb, but the power supply is changed. Power is 100 watt. Again potential difference, that is V, it is 110 volt. You have to find out the current here using the same formula once again. P is equal to V into I. So power is 100, V is 110 into current I. So I is equal to 100 by 110, 0 cancelled out, it is 10 by 11 ampere. So current flow in USA, that is 10 by 11 ampere. This is all about the question number 5. Now question number 6. Calculate the resistance of 2 km long wire of radius 2 mm. See, length is given, that is 2 km. Firstly, we have to convert it into meter. 2 into 1000. 2 into 1000 meter. Now, its radius is given 2 mm. Convert it into meter. Now find the area. Area is equal to pi r square. We know the value of pi, that is 3.14 into r. R is 2 by 2 millimeter. Converted into meter square. We get the value of area. Now, resistivity is also given, that is 1.72 to 10 to the power minus 8. So you have to find out the resistance. The formula used, R is equal to rho L by A. Rho is given, that is 1.72 into 10 to the power minus 8. We get the length 2 kilometer. We have to convert it into meter. We get the area. We find the area by using this formula pi r square and put the value over here for getting the resistance. This is the question number 6. So up to number 6 is done, and after that you have to solve question number 7, 8, 9 and 10, and that should be done by yourself, and this is the homework. So do it by using proper formula. Till then, goodbye.